time we saw how to install Ubuntu distribution, Ubuntu new Linux distribution on a virtual machine based on VirtualBox. Some of you experienced some problem in performing all the operation we saw, and this is probably due to the fact that the specific instruction for the virtualization purpose, which are embedded inside your CPU, are disabled by default on the BIOS, which is quite technical sentence to say, but this basically means that you have to simply enable this specific instruction to be able to run a virtual machine on your computer. Now, of course, since each PC is different from the other, I cannot provide you with a complete set of instructions which enable you to enable this feature on your computer. So it depends from case to case how to do it. Okay. However, for sure, I can give you a high-level procedure to solve the problem. And the high-level procedure is to switch off your computer, switch on your computer, enter into the BIOS, and then searching for the instruction set VTX and enable it. Okay? So if you are here in person, we will see how to do it later on. Good morning. Otherwise, if you are connected online and you are seeing me on YouTube, please send me an email reporting your PC brand and the type of PC you are using, so the number of the name of the PC you are using, and I will try to guide you in the activation of this feature. Of course, this only holds if you have any problem in the execution of the virtual machine. You may first of all try to see whether you are able to run the virtual machine as we did yesterday, and if this is not the case, just send me a proposal saying I'm using, I don't know, an Apple computer, I'm using an HP, and the number of the HP computer you are using, and we will try to solve the problem. This is it. So yesterday we were at the final part of the lesson. We were discussing about the command line user interface, and we saw a lot of nice command, quite useful from my point of view, but for sure you will see it during the program, the SSC program. Let me go back, let me conclude this part. Showing you some other, how can I say, commands. This is okay. And let me go to our virtual machine then to do it. So this is our virtual machine. As you can see, the virtual machine is exactly at the point we left it, and this is due to the fact that I was able to save the status of machine and reload it. Now, of course, let me first of all reset the status of the our command line interface, and introduce a new command, which is the command echo. So what is meant for the command echo? Well, the command echo is simply meant to reprint what follows the command echo itself. So if I want, for instance, if I want my command line write something like hello world, I simply have to write echo hello world. And this is it. Okay. So it may seem weird. Why do we need a command like echo? It seems almost useless because to let my computer write something, I need to write it completely just a line before. So why performing this operation? Well, the point is that we can, in some sense, redirect the output of the command echo into other commands. For instance, let me introduce another command, first of all, which is the command sed, which is a smart editor, let's say, for text. And the command sed is quite useful because it allows you to edit, let's say, a file without any problem, just providing the instruction that you have to accomplish on the entire file in the command line. Okay, so for instance, let's assume I want for replace the word hello with the word hi, for instance. How can we do it? In just one line in the command line? Well, we can use the command sed. And in particular, we can use the part of the command sed which allows us to replace the content of the file matching some kind of pattern with another word. Okay, so let me show you. It's much easier to understand once you saw it rather than try to understand by the explanation. So, for instance, I can do the following thing: echo hello world. This strange character, which is called pipeline, said, let me see, as hello. Now this command is quite, I mean, not really understandable at the beginning, but the point is that here we are executing the command echo, and we know that the result of a command echo is hello, comma, word, exclamation mark, and the result of this command will be passed to the sed command by using this pipeline. So this character is meant to say take the result of this command and pass to the next command. Okay? And this new command take everything from the input and substitute all the pattern matching hello with I. Okay? So for instance, I can do the following thing. By executing that command, I end up with a sentence hello word in which the word hello was replaced by the word hi. Okay? Let's see another example, for instance. By using the ls command, we know that we are able to see the content of the current directory, but of course, let's assume I want, in some sense, to cheat and replace one of the yes, please.
Just one question. Does the SCD, does it replace it only if it's a separate word, or does it find a pattern? The pattern?
Oh, it's a pattern. So you,
instead,
I mean, you are asking whether we can write exclusively one single word here, or if I can also write something like this.
if in the original string we had instead of hello a word which contained hello inside it.
Okay, let's try. So you're asking, what if here we have, I don't know, as hello. Okay, and let's see. Okay, so the set command, which I suggest you to investigate by using the man program, the man command, give you the chance to transform text. Okay, and in this case we are transforming exclusively one single line because we are handling the result of the command echo, but it might be the case we are working with more than one line. For instance, as I was saying, just have a look at the ls command. So let's assume we want to cheat in some sense. We want to hide the name of one specific directory. I don't know why. I mean, you are a spy and you don't want that anyone knows that the content of your directory is cp_test. Okay, that your home directory contains the directory cp_test. So how can we hide it from the ls command? Well, we can use ls pipe sed s. Again, sed is able to perform a lot of operation, but we are using the command s substitute simply because we are handling it. But I mean, you can remove or whatever you want. But in any case, let me show you this example. Cp test. Here we are. And as you can see, the ls program is returning, is outputting all the directory one per line, and we were able to remove the name of the directory we don't want to show simply by using the set command. Okay.
Is it a permanent change, or like
No.
if I write ls again, will?
So it's just for the output of that command. Okay. Of course, I can do much more complicated things. For instance, I can hide. Let me see. I can try to hide all the Okay, I can try to hide all the O and all the S. Oh, well, probably I can do it in this way. No, okay, in this way it's much better. So here I'm saying I want to hide. Oh, sorry, let me go back. By issuing this command, I'm basically saying that I want to hide all the patterns that match that, all the substring with that match that pattern, which is multiple instance of the character O, possibly also 0, plus S. Okay, so let me make another example. For instance, echo. In this case, I'll end up in this way because it tried to match the first character. But if I try something like this, I end up with a T. So since the pattern match OOS, because this character, this star means any possible instances of the previous character. Okay, so here I'm saying no matter how many O's there are before S, remove all of them.
Why didn't it do it in the
In the first one wasn't doing because in the first one, the first occurrence of O star S is the first S, because in this case we don't have any occurrence of O and one occurrence of S. However, we can also repeat all this operation for all the possible substring in the text by adding the G sentence, and we end up with deleting the whole sentence. Okay? So in this case, basically we are keeping repeating for all the lines in the output of the first command, we are keeping removing the multiple occurrence of O and S. This is it. Okay, let me go back to the slides then. Freeze for a while this virtual machine and go back to the slides. Here we are. No. Here we are. These are all the comments we saw until now. So you can find all of them inside inside the slides that you can download. This is the command we have just seen. The pipe or pipeline can be used to redirect the output of a command inside as an input for next command, and we see. But there is also another nice thing to do that can be done by using the command line interface, user interface. That is redirection. So what means the redirection? Means that you can take the output of a command, of a sequence of command by using pipeline, and place it into a file. So you can save the output of a command into a file in a really easy way, which is the use of the less than character. So by writing echo hello man, for instance, greater than message.txt, I end up with a file, which is the file message.txt, which contain the output of the echo command. Okay? And this particular pattern is unfortunately destructive. So if you have already a file named message.txt and you perform this operation, the file is overwritten and everything was in the file is now lost forever. Okay?
Where does it create the file? Like
in the current directory. Of course, you can also. So one of your colleagues is asking where the file is created, and by default it's created in the current directory. But of course, you can specify a path for the file, and according to the path, the file is created wherever you want. So if you want to create a file inside our directory cp_test, you simply have to write /cp_test/ name of the file. Okay, and that's it. Luckily, there is an alternative version of the redirection, which is executed by using a double greater than character. So if you write greater than and the name of the file, you end up in attaching the result of the previous command at the end of the file you are dealing with. So this is not more destructive, so everything was in the file is already in the file, but you are simply adding one last line. Well, I mean, in this specific case, one last line, but of course if the output of the previous command contains more lines, you end up in adding all that lines to your file. Okay? So again, this is much easier than opening a file, emphasize all you want to copy, or pressing Ctrl A, Ctrl C, and then copy to another file. So by using this syntax, you are able to redirect everything into a file in a really easy way. Okay. Now we will see in a demo later on. Now all the files which are those things that you are used to handle, also in Windows, are internally represented as numbers by the operating system. So once you open it, the operative system refers to that file as a number. And these numbers are called file descriptors. Okay? And these numbers are all natural numbers. And there are three really important file descriptors, which are the file descriptor 0, the file descriptor 1, and the file descriptor 2. Okay? These file descriptors correspond to the standard input, to the standard output, and to the standard error. What I mean by the standard input? The keyboard. Okay? By default. What I mean when I'm referring to the standard output? Monitor. Or better, your shell. What I mean by standard error? This is, tough to be understood at the beginning, but there is a place to represent the output of your file, and there is a place to represent the error produced by your file, in a way in which you can, in some sense, distinguish the error from the output. Okay? And so, by default, any POSIX systems allows you to save these errors in a special file whose file descriptor is 2. And this file is named standard error. And by default, the standard output and the standard error matches. Okay, match, not matches. So by default, if you are using a command line user interface, the errors and the output happens on the shell. But they are different from the logical point of view, despite the fact that apparently you got exactly the same, you get both of them exactly in the same place. Okay? Is it clear? Any question about this?
How do you understand which is which?
Good question. Now we will see it. Any question online? We will see. Okay, so let me go back again to our slides. Not slides, sorry, but virtual machine. And let's have a demo of what we saw just now. So I recall you that we have a directory named cp test, the top left of the output. So let's do what we saw just right now. Hello world. cp test message.txt. So what will be the result of executing this? Oh, by the way, let me see the content of the cp test first. Ls cp test is empty. We already know it. What if I write hello world? Cp test message txt. Well, the result of executing this command will be to create a new file in cptest. The file will be named message.txt. Here we are. And if we try to understand the content of that file, guess what? We end up with hello world. Okay, so easy. Now, let's try now to add a new end line for our file. So add new line to our file. New line. Let me call it new line. New line. So by issuing this command, I'm expecting to get a file named message.txt in cptest, having two lines. The first one, hello world, and the second, new line. But as we already understood, this does not happen. And the reason is that I'm using redirection with just one symbol. Okay, and by issuing that command, I'm saying I'm not interested in the content of the file message.com. Please delete it completely and fill it with the result of the previous command. And okay, so we understood that this stuff doesn't work as we expected. So let's try to use the double redirect character and see what's going on. New line, real new line. Can you see it? Okay, let me go here. Okay, if I issue this command, let me reset because otherwise people here cannot see what I'm writing. Resetting the terminal, and let's see what's going on here. I end up with two lines. So quite easy. Of course, I can mesh up all the comments we saw just a few lines ago. For instance, some times ago. So for instance, I can use the output of ls and redirect it into our cp message file. Okay, and for instance, I can also, let me reset again. Unfortunately, the beamer is not pointed in the correct position as far as I may observe. Of course, we can also use the pipeline stuff and doing something like sed, I don't know, sed s doc. So here I'm basically listing the current directory. I'm replacing all the occurrence of the character pair OC with the string ALLLLL. I don't know why, I mean it's just an example. And I'm redirecting the output into my file. Here we are. So let's see the content of the file. Here we are. Okay. What if I want to extract from a file exclusively those lines which contain a specific pattern? Well, we know that we can use the grep command. Okay. we did something like grep I think was inc profile, and this extract all the lines from the profile file which contain the pattern inc. Of course, let me reset again. Of course, we can redirect this output into our file, and if we try to see the content of it, straightforward, we get all the file include which was which was given in output by the grep command. And again, by using the pipeline, we can use the grep command on the list command. So by writing ls grep again do, for instance, I end up with all the directory in the current directory. Well, all the file and directory in the current directory whose name start with a capital D and O in output, and this can be redirected to the cp test message file. Okay, so extremely powerful. I'll invite you to try to do exactly the same thing with a graphical user interface. So to get all the file in a directory, to build up a file which contains all the file contained by a directory whose name starts with do. I mean, it's a mess. You have to do it by hand. It's not possible to do it in a graphical user interface, but we were able to do it quite easily in a command line user interface. Okay. Now, going back to the file descriptor, let's see how they works. So let me do the following things. Echo what? So by issuing this command, I'm saying that I want the output of the echo command redirect, okay, to what? To this ~1. ~1 stands for the file descriptor number 1, which is standard output. Okay, so if I do it, I see the problem right now. Let me rewrite it. Okay. Yeah. Because I mean the exclamation marks and the question marks means something really specific on the shell. So by using that command and mixing up the two, I end up in a mess. I can do it in a different way, but I mean that's okay. So in this case, I'm saying take the output of the echo command and redirect it to the standard output, which is just like saying just execute the echo command. But what about doing the following things? So by doing the following things, so by issuing this command, I'm saying that I want to take the output of the echo command and to send it to the standard error.
Standard error number 3?
No, 2. 0, 1, 2. And so if I execute it, I end up again exactly in the same situation, but this is due to the fact that by default the standard error and the standard output are redirected to my shell. Okay, so if you use it in this context, I mean they are totally useless. Using one
one or the other one, doesn't change anything. But let's see how can we use the standard error. Let's assume I'm executing a program which performs some weird thing. So let me do, okay, and the weird thing is to print in the standard error the content of the file message.txt, because the file message.txt might contain some kind of error. Let me do it error, for instance. So I can do it the following thing. I can try to print in the standard output the content of the file message and redirect it to the standard error. Okay, and then I can try to grab. Once I have executed that command, I may try to grab all the lines containing the double R. Oh, this doesn't work as expected. Oh, it may works. So let's try to do it. I get an error. But what if I change this grep and, for instance, I write a double T here? Well, let's try to do it. Error again. What's going on here? Well, the point is the pipeline is taking as input the standard input, well, the standard output of the previous command, and not the standard error. And since by using this notation, I'm saying takes the output of the previous command and place it in the standard error. Okay. So everything is printed on the screen. And the pipeline doesn't take anything anymore. Is it clear? Let me try to repeat it. So here we are, by issuing the command cat cp test message, I'm printing the content of the file. And the content of the file is error. By using this notation, so redirect to the standard error, I'm saying take the output of the previous command, which print in the standard output, which is meant to print in the standard output the word error, and redirect it to the standard error. So at this point, there's nothing is going to be sent to the standard output anymore. Okay, so the pipeline which is placed here doesn't take anything as an input. Okay, and so in both these cases the grep command isn't executed at all, because there are no lines passing through the pipeline. Is it clear?
So the pipeline only takes the standard output?
Yeah. So the pipeline takes the standard output and redirect the standard output as a standard input of the next command. So it's just a pipeline. Okay. Any question concerning this stuff? Is it clear? More or less.
So in both cases here, the grep command is not doing anything.
Yeah, in both cases the pipeline is not passing anything to the grep command. So the grep command is working, but is working with an empty input, because no lines is passed to the by the pipeline. But actually the pipeline does not receive any lines, because all the lines are redirected to the standard error. Okay, so this is cool. Let me see. Okay, let me enter here and see what if I try to execute cat test txt. So I try to execute cat test txt, I end up in an error message because the cp test directory does not contain any file name test txt. Now let's try to better understand the mechanism of redirecting through the different file descriptor. So let me write the following things. Echo standard output redirect to 1. Echo standard error redirect to 2, and that's it. So here I'm basically introducing two components in the syntax of the command line user interface, in particular in the bash syntax. The two new components are the parentheses and the semicolon. So the semicolon is meant to say, look, my command and here, and what's next is another command. So in one single line you can write many commands at the same time. And the parentheses are meant to say, look, this is a block of commands that should be executed as a single block. Okay? So if I try to execute this command, I'm basically printing into the standard output the word standard output, and into the standard error, as you can see at the end of the line, the beginning of the next line, the word standard error. Okay? Are you still there online? Any issues from your side? No. Okay. So let's try to execute this command and see what's going on here. As I said, again, we printed into two different files, the standard output and the standard error, but since they are both by default redirected to our shell, we got both result on the same, let's say, presentation. Now, what if I want to take exclusively one of the two commands and place the result into a file? So how can I distinguish what is the standard output from the standard error once I'm dealing with the output of this command? Well, let's try to perform, well, let me reset, otherwise you cannot see it. Let me try to perform the following operation. And let's try to execute it. So why right now we got exclusively standard error? Because the redirect is taking exclusively the standard output as input for filling the file text. Test txt. As a matter of fact, if we try to see the content of that file, we end up with standard output exclusively. So it's nice. We have a way to partition, in some sense, the content of the standard output and the standard error simply by redirecting it to a file. Okay? But what if I want to take the content of the standard error and not the content of the standard output? Well, in that case, let me add one single character. This is the character I want to add. So if just before the greater than character, I place the number of the file descriptor I want to handle. Now I'm able to take all the data streaming on that file descriptor and redirect it to the file test. So let me execute this command. As you can see, right now in the standard output we get standard output, okay, while the content of the file is now the standard error. Okay. Of course, this syntax also holds for the standard. Too fast. This syntax also holds for the standard output. So here we are redirecting the standard error to the file txt, test.txt, but we can also redirect the standard input to the file, the standard output to the file txt. Here we are. Okay. This is it. Okay. Oh, by the way, let me show you that if I remove, I want to let you notice that if I remove the parentheses in this way, the redirect commands refer to the last command. So if I run in this way, okay, I'm basically, by issuing this command and removing the parentheses, I'm saying the first command ends in the semicolon position. Okay, so this is a command apart, and it is executed as a standalone command. So the redirect we are performing here refers exclusively to the second command, or better, to the last command. And that's why I was using the parentheses at the beginning. Is it clear? No.
But the second command in this case is not doing anything, right? Because the standard error is going into the standard error, and then you're printing the standard output on the test.
Oh yes. Let's see the content of text. This is it. Okay.
Isn't it printing it in the standard error?
Well, it takes the last redirect command among the two.
So the one on the left.
The last one, which is that one. Okay. This is it. Okay, that's more or less all I want to tell you about the command line interface. Of course, there are many more commands, but I don't want to dive in. Oh, let me show you one last command, which is the sort command. Which is meant to sort. Which is meant to sort all the data. So if you have a file, well, let me use it on the profile file. So the profile file is this one. If I use the sort program, I get a file which is lexicographically ordered. Okay, and it's a nice tool because many times in searching a specific instance of the line you don't want to scroll the whole line, but you may sort it and then by using a dichotomic search going to the point. However, we will see it during the second part of this year. That's more or less all. Okay, that's all. Let me go back to the slide. Well, better, let's have a break, if you don't mind. Can we have a break? Okay. Do you mind? No? Okay, great. So let's have a break, please. 10 minutes, let's say. In the meanwhile, I'm going to... Sì.
Cioè, non ho capito sempre quell'ultimo comando lì, quando mettiamo, cioè leviamo la parentesi e c'è il semicolon e noi facciamo il redirect del standard error al standard error, insomma.
Perché
e poi un'altra
viene
volta
preso
il print.
come redirect l'ultimo?
Quello col standard error, diciamo il commerciale 2?
No,
Quello ancora prima.
l'ultimo sarebbe quello che sta nella linea successiva.
Cioè, non ho capito.
Redirect 1.
Uno? Sì.
Cosa è successo adesso? Mi ha dato spazio. Vabbè, vedremo dopo.
C'era tipo così, insomma. Questo qua tipo
Sì.
N e Y e ci sta il primo redirect che sta sull'1, il secondo sul 2 e poi c'era l'ultimo, cioè c'era la freccetta alla fine che...
Allora, il primo comando non deve essere considerato perché è un comando a parte, siccome abbiamo
esatto.
tolto le parentesi non conta più. Dell'ultimo comando quello che fa è prende l'ultimo redirect.
Ok, che sarebbe quello... Ah, ok. Sì, ok, ho capito allora.
Ho provato a schiacciare F10, ma
Aspetti un secondo.
mi dispiace se nella chat della lezione di oggi su YouTube mettiamo un link a un gruppo WhatsApp in modo da poter contattare direttamente
Anzi, mi sembra una cosa più ragionevole.
io lo so nel gruppo, per cosa? Sì. Sono più di me e tu.
Allora, proviamo a vedere spiriti. Come frasi. Virtualization technology. Premo il tasto invio. Enable. Exit. Save. Exit saving changes. Yes. Correct. Adesso provi a vedere la perché venga disabilitato francamente è una cosa che non mi è chiara e probabilmente vorranno evitare che qualche malintenzionato acceda al suo computer e poi lo utilizzi per far girare una macchina virtuale.
Perché è così, cioè...
Tutto è possibile. Però
Ma è possibile tramite... cioè è possibile accedere avendo attivato la configurazione del
è possibile accedere al suo computer appena lei si collega a internet,
Ok, quello sì.
indipendentemente da quello che è attivato.
ok, quindi accedendo al mio computer e se la virtualizzazione è attiva...
Uno potrebbe far girare una macchina virtuale,
Sì.
però il punto è che allora, se lei non è interessata a questo tipo di tecnologia, allora è chiaro che venga tenuto disabilitato. Ma se lei invece è interessata a questo tipo di tecnologia perché la usa abitualmente, cioè voglio dire, se chi ha progettato i processori ha messo queste cavolo di istruzioni nei processori per poter fare queste cose, perché disabilitarle a posteriori? Vendetemi un processore che non lo può fare, oppure non ha nessun senso.
Sì, certo. È una cosa di HP però.
E alcuni produttori lo fanno, ma dipende dal tipo di portatile, cioè se lei ha un portatile pensato per la programmazione, lo sviluppo, eccetera, eccetera, di solito sono abilitati.
E invece adesso vado un attimo sul sito di Ubuntu perché appunto io non sono riuscita a scaricare.
Ah, sì. Vediamo.
No, adesso devo ancora vedere.
È arrivata? Lei sta riuscendo a seguire? Che background ha lei?
Io in realtà ho fatto economia.
Qui a Trieste?
No, a Ca' Foscari.
Ah.
E poi ho fatto un minor in computer and data science, però era nel 15 Allora, questo è lo scritto.
No, il suo accento è un accento...
No, sono
Secondo me è tutta economia...
a Ca' Foscari. E ho avuto un percorso un po' strano perché quando ho finito il liceo ho cambiato 2 volte indirizzo. La prima volta facevo statistica, la seconda volta ingegneria aerospaziale a Milano. Poi ho avuto dei grossi problemi di famiglia e sono andata a fare il volontariato in Nepal e quando sono tornata volevo stare in Nepal a Milano, quindi sono andata a Venezia 3 anni fa e mi sono laureata lì adesso. Allora, sono sul sito, io avevo già, cioè l'avevo già
Scaricalo
scritto,
subito.
perché io sono l'avevo già scaricato.
No, proviamo, voglio vedere...
Che ci mette,
Vedi?
io ci ho messo un
Se lei fa
po'.
download... No, ci impiega tanto, non mi sto chiedendo, sto soltanto cercando di capire. Vedete che io dice MB64?
Sì.
Tra parentesi l'hai già scaricato.
No, infatti l'ho già scaricato, però quando poi ho scaricato la virtual machine e sa che quando mi chiedeva tipo versione.
Aspetta, adesso ho capito. Senta un po'.
Sì, allora.
Scusi, non so neanche io come fare adesso. Allora,
Sì.
no, vada su questo computer. No.
Ok.
Su questo computer, tasto destro del mouse. Proprietà. scriptate le opzioni di virtualizzazione, non si sa perché le dava soltanto 32.
Ok, ok.
Proviamo adesso. Allora, ricreiamo, tanto non l'avevo installata, proviamo a vedere cosa succede. Creiamo una nuova. Vediamo. Aspetta, guarda, facciamo così, scrivo uno tu. Ferma lì. Adesso scrivo il successivo. No, se lei 4 giri un po' te lo 4 giri la macchina. Così prendono il meglio. Le soluzioni. Si comincia allora okay, let's start again. So on the slides you can find basically everything we said, and there is a kind of deep description of also of the pattern thing we just mentioned. So the one in which I used the star to say any possible sequence of any length of O's, if you remember. So that kind of stuff goes under the name of regular expressions. So regular expressions are a way to specify patterns for set of strings, let's say. And for instance, the syntax you saw on the example, so square bracket AZ capital T dot describes all the strings which are either AT or ZT and having three different characters. Why? Because the dot means any single character. Okay. The square parentheses are meant to define a set of characters. So with that syntax we are saying take any character among A and Z. Okay. And after that set of any character in that set takes a capital T. And then after the capital T you may have any possible character. Okay? So the set defined by that pattern is a set containing, again, either AT or ZT and having as initial part of the string and having three characters on top. Okay? And here you can see many different part of the syntax of regular expression, but I don't want to go into detail. I rather prefer to show you an example. Well, first of all, let me add another piece of information in what I'm saying. That symbol, so I don't know how to call it. Do you know the name of this symbol? Of the first symbol in the first line? It's just like
Up arrow.
pardon?
The little up arrow.
Hat, right, hat. So the at means at the beginning of the line, and the dollar means at the end of the line. So for instance, you may specify all strings which start with something, simply placing an at the beginning of the pattern, or you may specify all the strings that ends with a particular pattern by placing at the end of that pattern the dollar symbol. Okay? And this notation of regular expression more or less can be used also by grep. So you can use grep, which is meant, I told you, to extract lines from the standard input or from file. You can use grep, well, you can use regular expression to specify different kind of stuff to be extracted from by the grep command. So let's assume we have a file named message which contains many lines, and we want to extract all the lines which at some point has a new, then a certain number of any possible character, possibly also 0, then a B, and then again a certain number, possibly 0 of character. Okay? So in this way we are basically extracting all the lines which contain U, a letter U, followed by at some point eventually by a letter B. Okay? And here what you get. Now let's assume we want to extract instead all the lines which contains a B and a sequence of character, let's say, and or the word cool. Again, in this case, you can use the parentheses to specify sub regular expression, and the pipeline to say choose one of the two regular expressions. So here I'm saying I want to extract either, and this is due to the pipeline, either a line containing a B and then followed by something, or the word cool. Okay. Okay. This you don't know the content of this file, but I mean, if you look into the slides, there are the full way to build the file message txt, which return exactly this result. Okay. Now you may wonder why we use this backslash notation here, this slash notation here, and this is due to the fact that we are embedding all the regular expression inside how can I say, the quotation mark. So to avoid confusion with a standard string, we use these symbols. These symbols are called escape symbol, and means that what comes after that symbol is not a standard character. It's meant to be a part of the regular expression syntax. If we don't use that escape symbol, we end up inserting into message a string containing b dot, well, better, open parenthesis, b dot star, close parenthesis, pipeline, open parenthesis, cool, just close parenthesis. Okay, so the string, not the regular expression. So to avoid this and to tell the grep command that that string is meant to be a regular expression and not a standard string, we have to use the escape character. More or less, it's clear. Is it clear? 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 Any comment online? Please don't send any number on the chat.
I tried sending a link.
Yeah,
It didn't work.
yeah. I mean, but not numbers, please. Okay. Because right now your numbers is online for everyone in the world. Okay. So this is it. Clear. Great. Let's move on. Another nice things we can do with the command line user interface is programmability, and that's why I say that you can use command line interface to program. What I mean by programmability, I mean that you can, in some sense, teach your computer what you want to do. For instance, one command, available command for the bash is the for command. The for command keep repeating a block of instruction for a set of data, let's say. The idea is that for every possible value of I, in this case, among those which are specified by the command between in and do, and we will go back to that command in a while, I keep repeating echo test underscore and the value stored into the variable I. Okay? So at each iteration of the for loop, I assume a different value, and at each iteration of the for loop, I'm keeping echoing test underscore and that value in the standard output. So let's go back to what is written in between of the in and the do. So what is written in the middle of, in between of the in and the do is a command again. And in particular, this command tells me that I need to evaluate, and this is done by specifying dollar and parentheses. I need to evaluate the command, again, seek13. What's the command seek13? Well, seek is a command for the command line user interface, so you can try to use it right now on your shell. And is meant to produce a sequence of number. Okay? And in particular, we want to produce the sequence of number going from 1 to 3. So the output of the command sequence 1, 3 is a sequence of the number from 1 to 3. This sequence is kept as an input for the I variable. So the I variable at each iteration of the for loop, assume one different number. Assume as a value one different number. And so at the end of the execution of this for loop, we redirect the output into the test.txt file. And that's why if we cut the content of the txt file, we end up with 3 lines. The first one is test 1, the second one is test 2, and the third one is test 3. No? Again. Oh, that's the type, my typos. Okay? Okay. So quite easy. I don't want to go into detail according to the programmability of the shell, because I mean we will focus. I want to focus more on the C programming language. However, I think it's really nice to know that there is this chance. So you can build up your script to perform various kind of operation on the shell and automatize your let's say process. I don't know how to specify that. Now we saw that we are working on a multi-user operating system. So and we already saw that not all the users must have exactly the same privileges. So, for instance, if you and your little brother or sister are working on the same system, you don't want that your little brother or sister mess up your stuff. Okay. You don't want him to be able to send email in your name. You don't want to. Okay. So the point is that all the users on the system you are using have different privileges, and the privileges depends, of course, on the rules they are on the system. There may be host user, let's say, and there may be super user. By super user, I mean user which are enabled to do anything. For instance, because they are the administrator, so they keep the system update, they create new user, they own the system, and so on and so forth. So, of course, modern operating systems provide the chance to be a super user to everyone who has installed the system, and in POSIX system, the super user is usually called root. And we saw it yesterday, I think. We were talking about the content of the root directory, and we noticed that many of the, well, all the directory in the root directory are owned by a user named root. That user is the super user, the user which organizes all the stuff in the system itself. And that's why you don't need to specify any user root during the installation, because by default the system must have a user root. Okay, this is it. Well, there are two possible strategies to implement the user root. One strategy is to have an actual user on your system. Another strategy is to use a tool which allows you to impersonate, in some sense, to become a user. Now, Ubuntu and OS X, for instance, use a tool named sudo, which means super user do, okay, to to let you execute a command just like you was the root. And the idea is that you are allowed to do it because there is a list of users which are allowed to impersonate the super user. And since you install the system, you are automatically including this list. So if you try to create a directory into the root, as we did in the slide, you end up in a failure because, of course, as a standard user, you are not allowed to create anything in the root. You are not the root user, I mean. You are not the administrator of the system. If you are Alberto, the standard user, you created. So you cannot create the directory test inside the root directory of your system, but you can do it as super user. And to do it as super user, you have to use the command sudo. So by writing sudo, make dir /test, you are now trying to create the test directory into the root directory of your system as a super user. And in that case, you are able to do it. You are able to accomplish the goal to create your directory. Okay? So the sudo command is meant to allow you to execute operations which are exclusively allowed to super user. Okay. Okay. Now we understand that not all the users are the same on our system. There are super users and there are the people. And but you may wonder, how can we install stuff in our system? Well, there is a nice graphical tool in Ubuntu which allows you to select graphical tools. For instance, I don't know, if we decided to go for the minimal installation, you avoided to install all the Office stuff, and you may want to install this Office stuff in the following up of your installation. You can do it by using the graphical tool that is meant to do it, or much better, you can use the real tool which is used to install the stuff in Ubuntu, which is named APT. APT is Advanced Packaging Tool, and it's a kind of ante litteram market for software market. Okay, so the idea is that for anything you need to install, you can use APT. And you can do it in the command line, which for graphical tools is not really useful because, of course, you can, if you want to install the Office tools, you can use the graphical part, the graphical tool for installation. But if you want to install, for instance, everything you need to compile something, it's much easier to use APT rather than use the graphical tool. The advantage is due to the fact that APT solves all the dependencies. So if you need to install the compiler, for instance, to install the compiler, you may need some libraries, and this library may need other libraries, and so on and so forth. And APT takes care for you of all this stuff. So once you ask to install the compiler, APT tells you, look, to install this stuff, you need also this library, this library, this library. All this stuff, we need to install all this stuff, we need to download, I don't know, 100 megabyte. Are you sure you want to download it? You press yes, and everything goes fine. So at the end, eventually, you will have all the stuff you need to compile a program on your system. Install. So to do it, you simply have to do sudo apt get install build essential and squeeze and press yes, and you end up with all the tools you need to compile something. me do it. Can we do it? Yeah. Let me do it just to be sure that everything works as expected. So if I write box. Now if I try to do apt get install build essential, I try to do it, I'm going to get an error, and this is due to the fact that to install something I need to be the administrator of the system. So to install something system-wise, I need to be the administrator of the system. So I need to prepend the sudo command to my previous command, sudo. So I'm trying to execute something by as a super user. The something I'm going to execute is the apt get command. So I'm getting from a repository which may be, I don't know, everywhere in the world, all the software related to build essential. Now why build essential? This is because I'm telling you that this is build essential. What if you are trying to search for a specific software? We will see it later on. So if I squeeze, if I press enter, I end up in this prompt, and the sudo command requires me to write my password to be sure that I'm the person who's trying to execute the command. Okay, so I'm writing my password, so the password I'm using to enter into the system, and this is it. Now you miss some part of the output. Just let me scroll up. So as you see, I'm prompt to the fact that I'm now acknowledged to the fact that additional package will be installed to install the build essential package. And this package will include I don't know, many things that are unknown to me. For instance, the main pages for developers, just to tell you one, or I don't know, this compiler, the GCC compiler, and so on and so forward. But I don't have to take care of all the names. The apt tool is simply telling me, look, I'm going to install something more than what you asked for, because all this stuff is required to install that package. Moreover, there are also some suggested packages, but I'm not going to go through them. And now it's telling me, look, the other packages are needed, but there might be some of the other packages needed already installed in the system. So what are the packages that should be installed from the scratch to install build essential? These are the packages which are needed to install from the package. And here we have at the almost at the bottom of the output, we have the size of the package we have to download from internet. So if I press enter at this point, now all the packages will be downloaded and installed in the correct order.
Does it install them all in the, download them on the home
Pardon?
directory? All in the home directory?
No, this is system-wise. So this installation is done system-wise, and that's why we are required to use the sudo program. Because if you want to install a software on your home directory, you don't need the administrator privileges. Now, right now is performing a set of operations required to set up everything correctly. So, if you downloaded the main pages, you have to it has to update the database on main pages, so that, for instance, if you use the apropos software, the apropos command, you end up in finding everything has been installed right now. Okay, so it may take some time. Eventually, we end up with the prompt again, and right now I installed my GCC compiler, and if I try to run it, I end up with an error because I haven't provided anything to compile at the moment, but it works. Okay. Let me try to install another software by using the graphical user interface. The graphical user interface to install software uses so the back end of the graphical user interface to install software uses apt and another packaging tools that I'm not going to mention, and so you may find more software here. Well, first of all, you ask for how can I find the software if I'm searching for. You can use apt cache search. I don't know, Office, for instance. In this way, I was provided with all the possible software which can be downloaded by using apt, which is somehow involved with the word Office. Just to tell you, I don't know, Writer to LaTeX is a package for OpenOffice, which is a set of tools for the Office. I don't know, the schema of Office 2003, LibreOffice, and so on and so forth. But for this kind of tool, of course, probably the best way to install software is this icon, which is the graphical tool for searching and installing software. If you click on it, after a while, again, here we are emulating a real system on my laptop, which is not brand new, so it may take time also because of that. Here we are. So I don't know if we are searching for something related to art and design, just squeeze it. We don't have anything here. This is due to the fact that it's not really update all the stuff, but actually let me try to search for, I don't know, GIMP. Okay, GIMP is a tool for manipulation, for graphical manipulation, just like Photoshop, something similar to Photoshop. And you were presented with these two images, a description somewhere down here of what it is, some reviews, and so on and so forth. You may decide to install it. If I click on it, I'm going to be asked to enter my password, which is used by the sudo command to acquire a privilege to install system-wide this tool, and so you end up in that stuff. Let me see. Oh, this is probably due to the fact that check then to window. No, not window, but visual code. Still searching the code. For instance, this is a nice tool to write code. I don't know whether you have ever used it. I'm personally use it because it's quite useful because I highlight any possible error in your code and so on and so forth. This is made by Microsoft, and as you can see, it's distributed also with Ubuntu. So that's it. Let me try to install it just to let you see how it works. My authentication, so my password, I press enter, and it's now installing it. Quite easy, almost just like your mobile software to install. Probably the only difference is that here you're being asked of a password. But
is the password the one that we put for when you install the VirtualBox, or the actual password for the computer again?
no, again, is the this password is the password you enter when we were installing the virtual machine. So is the password of your user, the password you are going to use every time you enter in your home directory, let's say. Okay, it takes time, but this is the idea. This is more or less all. Let me see. Can we conclude the installation? Okay, here we are. So again, we have a different button here which is meant to remove the software. So again, we can squeeze it and remove the software, but let me show you that we have now installed. To get, well, we have two ways to get to the software. We can squeeze this button and we end up with all the software installed in our environment. Of course, we are missing some part of the name, and this is due to the limitation of the beamer we are using here. So in the screen on your computer, you will see everything. And if I click on Visual Studio, eventually, again, we have to wait. I end up with Visual Studio, and this is the icon of Visual Studio, and that's it. Any question? Easy, isn't it easy? Yeah, great. So let me go back. I want to go back to the presentation. Just for the last line, actually, for the last slide, actually. So what we are going to see next, we're going to see the first C program. Until now, we have never talked about programming by using the C programming language. So right now, it's time to have a look at the program. see what is called types, variables, and so on and so forth. So if you are already aware of any imperative programming language, you already know what I'm talking about. I'm going to talk about. So, here we are. Any question? What's going on? Why can't you see? Well, okay. Okay. So finally, let's move to the programming stuff. So as I already said, the C programming language is an imperative language, meaning that all the programs in the C programming language are sequences of instructions, or commands, if you prefer. So at the beginning, all the programs at the beginning of this part of the course, so all the programs will have this structure. So this is a template, let's say, for all the programs we are going to write. I'm not going at the very beginning, I'm not going to tell you what's the meaning of all the stuff in this template. Let's assume they are correct, and for the moment we are not going to bother about them. Okay. Again, if you came from different programming languages, probably you may guess what's going on here, but I will eventually tell you all the truth about this template. Okay. Can you trust me for I don't know, two lessons, let's say? Yes? More than my daughters. Okay. So, what are instructions for the C programming language? Well, they are basic commands. So, as I already specified during probably the first lesson, for sure it's not something like goes to the grocery to buy milk. It's something low level. And we can syntactically emphasize all these commands, this instruction, by searching for semicolons. So every instruction in the C programming language should be concluded by a semicolon. Okay? And because of that, more instruction can lay on the same line, exactly as we saw for the command line interface, user interface. So if you have two instructions, but you end up all the instruction by using a semicolon, you can easily distinguish them. So the very first thing you have to learn in learning computer programming is to comment your code. Why? Because as soon as you start writing thousands and thousands lines of code, after a week, for sure, you will forget everything you wrote a week before. So it's really important to write comments for yourself and for everyone is reviewing your code. Okay? It's a way to simplify the code, because while the syntax of any programming language is easy, I mean the background of each line of code is maybe a little bit tricky to be understood. So writing comments is really important, And okay, this is it. And in the standard C, which is the ANSI C, so ANSI means let's say standard is the standard of C. We have exclusively one way to comment, to write comment, and this way is the one you can see on the slide. So we have a backslash, a star, the comment, a star, and a backslash. And this is the only way you can comment a piece of code. Well, piece of code. You can write a comment inside an ANSI C program. Okay. Despite this, modern compilers usually allows also to use the version which was the comment version which was introduced for the C++ programming language, which is a sort of a song for the C programming language, which is the double backslash. Okay, so if you write // means that everything after that // is a comment on the same line, and you don't have to close, let's say, that comment. So as you see, usually we have two different ways of commenting or providing a comment inside our code. The first one must be open and closed. The second one is closed by default by ending the line. So this is a piece of code. Please don't focus on the first part of the code, just focus on the comment. As you see here on the slide, we are starting the comment after a semicolon. We are writing a few lines, and all these lines are on the same comment, and then we close the comment. Okay? And this is the standard way for commenting the code. Now, what is a variable? A variable is a really important notion for any possible imperative language. So probably you are already aware of what I'm talking about. But basically, they are containers of data, and they are equipped with a name and a type. So any variable has a name in the C programming language, has a name and a type. Well, the name is quite easy to understand what I mean. What is a type? Well, the type is the kind of data you are going to store in that variable. So we said that a variable is a container, just like a box, but not all the boxes are the same. There are small boxes, big boxes, and so on and so forth. So depending on the kind of data you want to insert into your box, you have to specify if you want a big box or a small box. And this is done by specifying the type. But this is not the only reason to specify the type. It's not just something related to the space needed to store a data. It's also something related with the kind of operation that you want to perform on that data. For instance, while it might be interesting to divide a number, has no meaning dividing a character. Okay, so the types not only specify the kind of value that you want to store, but also which operation you are going to perform on that value. Okay? So, as you cannot see on the slides, but I trust me, it is written on the last part of the slide. Type specifies set of values can be stored into the variable and the function that can be applied to that value. So Okay, so we know that a variable has a name and has a type, but how can we specify it? Before using a variable, for sure we need to say, look, this variable has this type. How can we do it? Well, we do it by declaring the variable. So if you can, again, if you came from Fortran or Java or C++ or whatever you want, I mean, for sure you already know what I'm talking about here, but if you're coming from Python, for instance, this is not the case. So in the C programming language, you have to declare a variable before using it. So you have to say, look program, I'm going to use a variable whose name is people and whose type is type of people, okay? And to do it, you can simply use this basic syntax. So we will have the type of the variable at the beginning, a space, and the name of the variable, and then a semicolon. From that point on, the name of the variable will be used as a shortcut for the box, for the variable itself. Okay? So instead of saying take the value inside the variable, we simply need to mention the name of the variable. And that will be enough to deal with the content of the variable itself. Now, which names are allowed for the variable? Well, the names admitted for the variable are the one which can be represented by using this regular expression. Okay, and the idea is that basically any strings containing numbers from 0 to 9, capital letters, standard letter, and underscore and minus, but no, minus no, underscore are admitted, but the initial character of your name should not contain a digit. So they should not contain, shouldn't be a digit. Okay? So you cannot name a variable, for instance, 0 people. Okay? You can name it people 0, but not 0 people. So the first character in the name, in the variable name, must not be a digit. And beside this simple rule, all the reserved word cannot be used as a variable name. What do I mean by reserved word? Well, we will see that in the C programming language there are some words which are reserved for specific tasks, and so we cannot use them to represent the name of a variable. For instance, two examples. If you go back to the template I showed you before, there were a word named return, and there was a word named int. These two words cannot be used as a name of the variable. And so if you came from languages just like, I don't know, Pascal or Delphi probably, but almost certainly you are not coming from Pascal or Delphi, but this is just to let you know. The C programming language is case sensitive. Okay, so this means that calling a variable ciao, or calling a variable ciao with the C for the first letter as a capital letter makes a difference. So capital letter and standard letter are different for the C programming language. Well, this is not true in some imperative language. Okay, so now we understood how can we call how a variable can be called. So what are the basic type of the C programming language? Well, the basic types of C programming language are those that you can see in this slide. We have a type named char, which is meant to store both standard character, let's say, okay? So the character in the Latin language, and small integer values. In particular, integer values going from -2 to the power 7 up to 2 to the power 7 minus 1. Okay, so all the integer value in between of these two values can be represented in a single char variable. And this because the char variable takes exactly 8 bits. And by using 8 bits, you are able to represent all the integer value in that domain. Oh, by the way, these data are not standard. These data type are not standard. So the standard specify a minimum range for this data type, but it could be the case that actually in some architecture the char data type can store a larger domain of values. Okay, and again we have the short data type, which takes more or less the same integer value the char takes, but this is due to a specific architecture. So we know that the short data type can store all the values going, at least all the values going from -2 to the power 7 and 2 to the power 7 minus 1. But this is the minimum range. So it can be the case in a specific architecture you got short type which is larger than this range. We have the integer type, which takes at least 16-bit. The long int type, the long int type, the floating point, which is meant to represent, I mean, not all the real values, but a subset of the possible real values. And this is due to the fact that, of course, real values are infinite, while the number of values that you can represent by using any finite sequence of bits are finite, and so we have to decide which one you can exactly represent and which one cannot be represented. Then we have the double real values and the long double real values. Please remember, these ranges are the minimum ranges established by the ANSI standard. So it can be the case that in your architecture, for instance, the integer have a wider range of number. And by the way, this will be the case. Okay? Almost for certain. Any question? Is it clear? You did online. Okay. So another interesting thing is that you can use a special word named unsigned to shift the range of number representable by using the data type we see just a while ago, and take not the integer values but the natural values. So instead of taking, for instance, all the values between -2 at the power of t, for instance, let's consider the case of the unsigned int. The int value for sure contains all the value going from -2 at the power of 15 up to 2 at the power of 15 minus 1. Okay, by using unsigned int, I'm getting exclusively natural number going from 0 up to 2 at the power of 16 minus 1. So I'm in some sense using the negative, the part of the representation used by negative number for representing more number on the positive side. Okay, and this would be quite interesting because if for instance you try to take the largest value representable by an integer number and you try to add one more to increase it by one, you end up getting a negative number. Okay, I repeat it. Since you can represent all the number above 2 to the power of 15 minus 1, you can represent it by erasing all the negative part of that range. If you take in the case of signed type, if you take the largest number representable in the range and you increase it by 1, you end up with a negative number. Okay. So again, for example, take the largest number representable by an integer variable, increase it by 1, print it on the standard output, and you get a negative number. And why? Because there is what is called overflow. So in some sense, you are trying to represent a number which is larger than the one you can represent by using that type. Okay? Okay, so going back to declaring a variable, we saw syntactically how it works. Let's try to have an example of how we can declare a variable. So, for instance, if I want to declare a short two variables s and capital S as a short variable, I can use the syntax you see on the second line of the slides: short space s, comma, capital S, and semicolon. Okay, this is a shortcut. Instead of declaring one single variable, I'm declaring two variables at the same time, and to do it, I simply use the usual syntax in which I contract, let's say, the repetition of repeating all the time the same type with a comma. Okay, so in this way, I'm basically declaring two variables at the same time. If you have a look at the line just after the writing the sentence floating point types, we have a line more or less in the middle of the slide. We have a line in which we can see float space f semicolon, and this is the declaration of the variable f for variable f of floating point type. Okay, so quite easy. Any question about this? Were you aware of this declaration stuff? Yes, I think so. Any one of you was coming from a language in which there were no declarations? No. Okay. So how can we store a value inside a variable? Well, to store a value inside a variable, we can use the assignment. The assignment is simply something executed by using this syntax. In this syntax, we see that we are dealing with a command, with an instruction, better. We are taking into account a variable, and we are setting the content of that variable according to the expression which is on the right side of the assignment. So on the left side of the assignment, we have the name of the variable. On the right side of the assignment, we have the expression we want to evaluate and to place, and whose values will be placed into the variable. Very easy. For instance, here we have few examples of assignment. S is, if you remember, was a short variable, so we are assigning and is able to store all the values from, at least all the values from 2 to the power 7, minus 2 to the power 7, up to 2 to the power 7 minus 1. So we can assign, for instance, safely the value 4. And there we are doing it. So we are assigning to S the value 4, and then we conclude the instruction that way. Then there is another instruction which takes the variable I, which is an integer value, and we assign to the variable I the content of the variable S. Or better, we assign to the variable I the evaluation of the expression, which in this case is exclusively a variable S. So as you can see, we are moving from a data type which can store shorter number to a data type which can store larger number, and a wider range of number, let's say that. Okay, and this is admin. Then we have the third assignment in almost at the middle of the slide, in which we are taking a character variable C, a char variable C, and we are assigning that variable with a character A. Now, how can we represent into the C programming language a character? This is done by using the apostrophe. Okay, please notice the approach in C programming language, quotation mark and apostrophes are different kind of things. So if you write quotation mark A, quotation mark, you mean the string which contains A. By using apostrophe A, apostrophe, you mean the character A. They are two different things. And for instance, again, if you came from Python, there's no difference between apostrophes and quotation mark. But this is not the case in the C programming language. They are really, really different kind of things. Okay, and this is it. So as I told you, actually the right side of the assignment can be any evaluation, and in particular can be algebraic expression. So if we are dealing with a variable which is able to store for instance, in this case, natural number, we can apply algebraic transformation expression. We can evaluate algebraic expression as in the line you can see on the slide, and the result of that algebraic evaluation can be stored into I. This is, I mean, if you are not used to programming language, this is quite interesting, because you have the same variable in two sides of the let's say equation. This is not an equation, this is an assignment, but I mean, this may seem weird, but the point is that on the right side of the assignment you have what you had before the assignment itself, and on the left side of the assignment you have the destination of the evaluation. So basically you are saying, in this line you are saying, I'm taking what was contained into the variable I just before the execution of this assignment, and then I'm evaluating all the algebraic expression, and then the result of that expression will be stored into I. Now let's have a look at the last two assignments. The first one is f is a floating point variable. It's a float variable. It's meant to represent, I mean, a subset of the real values. so it's quite understandable that you may want to assign to that variable, for instance, 4.1. Nothing special. The last line is a little bit strange because you have an integer value and you want to store into the integer value a non-integer value, so a floating point number. So in some sense, it's just like you have a small box and you want to place an elephant in it. So either the box breaks up or you squeeze the elephant. Okay. Now, in the C programming language, of course, we have something called casting. What is casting? Casting means that you magically transform a data type in another data type. Okay? And whenever you try to assign an expression which is of, let's say, data type meant to represent a certain kind of data, you want to insert that data type, that data, inside that variable whose data type is meant to represent a wider set of values, then you have what is called implicit typecasting. So the C programming language implicitly try to, without any requirement from you, implicitly try to accommodate all the stuff. Okay. And whenever the variable in which you want to assign the value is more general than the type, or better, whenever the type of the variable you want to assign the value is more general than the type of the value itself, the value is preserved. So if we take, of course, an integer value and we try to assign it to a floating point number, okay, well, usually the value is preserved. While the other way around is, of course, not true. So we have just seen an example. We were trying to assign the value 4.1 to the variable I. So for sure, variable I is meant to represent the integer number, so 4.1 is not representable by an integer value, by the integer variable. And so there might be approximation in that case. There is another kind of typecasting named explicit typecasting. With explicit typecasting, we are forcing, in some sense, the expression to assume a certain value. For instance, and to do it, we have to use the syntax you can see here. So, into parentheses, we are going to place the type we want the expression assume, and then we place the expression. So, going back to our example in which we were trying to assign the value 4.1 to I, we can explicitly do it by writing I equal to parentheses int 4.1. In this way, we are telling the compiler, we know that we are what we are doing. We know that we are going to approximate that value. Don't worry, this is not a fault of our misunderstanding of what's going on here. We know that we are approximating the value in this way. And by using explicit typecast, we can do many nice or nasty, depending on what you mean by nice things. For instance, you can turn a character into an integer value, perform an addition, and then turn back to a character. Okay, so you take A, you turn it into a value, you sum 1, that value is turned back to a character. Which seems weird, but it's not really weird, and the reason is not weird is because the characters are represented by using a special code named ASCII code, sorry. And the ASCII coding basically assign to each representable character a number. So by doing this operation, we are taking the character we are representing, we turn it into the corresponding ASCII number, we sum up one, and we get the next character in the ASCII representation, and then we end up with turning back to the specific letter corresponding to that ASCII code. So since all the characters in the Latin alphabet are subsequent, so are alphabetically ordered. The code are alphabetically ordered in the ASCII coding. This is extremely useful if you want to turn a string, if you want to cap lock the string, let's say. Okay, so you take a small string and you want to get the corresponding capital letter string. You simply have to add the difference between the small a and the capital A to all the characters in the string, and you end up with the corresponding capital letter string. And yeah, you can also do find things as the one you can see on the last line, or you should see on the last line of the slide. So the last slide for today, I think, because I'm tired. I don't know you, but I'm really tired right now. In C programming language, there are two kinds of division. Despite the fact we have one single symbol to represent them, we have integer division and floating point division. And the symbol to represent that is the standard one. I mean, if you have already programmed in any computer language, you know that slash is used to represent the division. But the C programming language is selecting the most appropriate according to the types of the operands. Okay, so if I perform I divided by 2, I end up with an integer division because both I and 2 are integer values. Okay, if instead one of the two operands are a floating point number, the C programming language automatically selects the floating point division. Now, how can you understand if you are doing a floating point division or an integer point division? Well, of course, if you are dealing with the integer and you try to divide 5, for instance, 5 by 2, you end up with 2. And if you multiply back 2 by 2, you end up with 4, which is different from 5. Okay? Of course, this is not an arithmetic operation. This is an integer operation, and it's quite different from what we did, what we do in calculus, for instance. Okay, if you take a value, you divide by 2, you multiply by 2, you get the original value. This is not true for integer division, of course, and that's the point. Okay, this is it for today. Tomorrow we will conclude our review of the basic syntax for the C programming language, and we will try to do some exercise. I will give you some exercises, so if you have a laptop, would be much better, because you may try to solve the exercises in class with me, and you may say why I'm getting this error and why can cannot really try to solve it this way. Okay? It's not mandatory, but I mean, it could be useful for you. Yes, please.
We have to download some software.
Pardon?
We have to download some programs and compiler.
Well, of course, you have to download Ubuntu, install it in virtual machine, and so on and so forth. I mean, again, it's not mandatory, but it's much easier. So to have Ubuntu installed in a virtual machine is not mandatory. I mean, you can use Windows or Mac OS X or whatever you want, but I mean, it's much easier to be consistent with what I'm doing. Okay, so if you get an error, we know that the error is common to everyone. Otherwise, it could be due to the operating system you are using, could be due to the compiler you are using, and it may take time to figure out what's going on with the error. Any question? Are you tired? Good. For me, because I'm tired too. I thought I was too old to have lessons for 3 hours in a row, so now I know that it's not because of my age, but not only because of my age. Okay, that's all. Thank you so much for attending the lesson, and see you on Friday. This is Friday. Okay, thank you. Bye.